We are going to now go over the homework assignment that I gave you. And this is really, as I want it to be, it is not only going over the homework, but it is a wonderful opportunity to review what we did in class yesterday, because we did so much, really. So this is the homework review. And we start with section 3.1. So this is the chapter 3 homework review. And these, I gave you a lot of problems, but they were fast. Like on page 5, problem 1B. These are very, very quick problems. Like this was the problem. Okay. Obviously, very easy question. This means, this is -6 times -6. And that's positive 36, obviously. So that's, pretty easy question. Nothing spectacular there. And then, it builds up with all the things we learned yesterday. Problem E was 6 to the -2. 6 to the -2 is, so, right off, you start out with the negative makes this a fraction. And then that becomes 1 over 36. Okay, so the negative, don't forget, means a fraction. Better than a fraction. The negative means if because the negative could be in the denominator. In other words, you could have a problem like 3 over 7 to the -1. And, this doesn't mean a fraction. It means wherever the 7 is that has a negative, you put it in the numerator, right? That's what it means. So that's what a negative means. It means if something is in the numerator, it goes to the denominator. If something is in the denominator, it goes to the numerator. If it's a fraction, you flip over the fraction. All those things apply in this, like, for example, problem H is exactly what I'm talking about. 1 over 7 to the -1. Okay, so this problem means 7 over 1 or 7. That's what it means. Just flip it over. Okay, stop me anytime now. Now we go to problem on page 6. We go to problem K. So the problems are getting interesting now. Problem K, -3 to the -2. Okay, now this is not this. Get it? This is the big mistake that students make. So unprepared today. It's like pathetic. Don't review me today on Rate My Professor, that's for sure. So you see, these two are very, very interesting problems because this means negative, well, first of all, this, and then 1 over 9, right? Now this means kind of take that negative and put it over there so it's not bothering anybody for a while, and then work with 3 to the -2, and this becomes 1 over 3 to the 2nd, or 1 over 9, but then you bring back the negative, so it's -1/9. That's the difference. The difference is this problem is +1/9. This problem is -1/9. Do you see the difference? Is there anybody who's unsure about what I'm talking about here? Okay, now that wasn't a problem. I just, wanted to show you the difference. I think we did that in class yesterday. Problem N is the next one on page 6. This is a, interesting problem. They're getting more and more interesting as we go through this. So this is what it looks like. And once again, you see, that negative should be put aside for a minute. Put it over there and just look at -3 over 4 to the -4th power. Now, again, the negative means take this fraction and flip it over. And then make the exponent the 4. See, so this with the negative means simply flip it over. Flip the 3/4, make it 4/3. Now you do negative, negative anything to the 4th power is going to come out positive. Negative to any even exponent will always come out positive. So you could just don't worry. But that's not related to this negative that we're bringing down here. This negative just kind of is hanging out until the end of the problem. This negative has a very easy job. It's just sort of hanging back, watching Brendan's TV while everything else is going on. And then when the problem is all done, then it's okay, you'll be put into the problem. Now, 4 to the 4th power. Again, you could use your calculator if you like, and you could put in 4, because this is equal to really 4 to the 4th power divided by 3 to the 4th power. See, remember what we said yesterday? That this would be equal to this. Now, you may need your calculator. So let me put it up here. So negative is just sort of hanging out, watching TV. 4 to the 4th power, I happen to know is 256. One of those things that, you pick up knowledge of. 4 to the 4th. And what I did basically, just so you know that I didn't just memorize it, I did 4 to the 4th power is equal to 4 to the 2nd power times 4 to the 2nd. And I happen to know, as everybody sitting here knows, this is 16 times 16, which everybody knows is 256. See? Or you could just multiply on your calculator, 16 times 16. Same thing is true for 3 to the 4th. 3 to the 2nd is 9. 9 times 9 is 81. And now the negative that's been hanging out doing nothing comes back into the problem, and there it is. And this is the answer to the question. A little tricky, right? Because if you look at the problem, right away, all you see are negatives all over the place. You got a negative outside, you got a negative inside, you got a negative exponent. This problem is intended to really drive people crazy because of all the negatives. But this is the way you handle it, and I hope that's clear. If it's not, please say something. That's what we are here for. Problem Q. Problem Q. 12x y to the 0. Okay, well, here they're simply testing your knowledge of the 0 exponent. And keep in mind that this problem is intended to throw you off and make you think that this is the problem. The answer to this problem is 1. The answer to this problem is simply 12x. See the difference? Study the difference. What a difference a set of parentheses can make, right? It changes the whole problem. In this problem, everything over here is being raised to the 0, which makes that 1. Here, only the y is being raised to the 0, which makes that 1, and then 12x. And if you're unclear about that, say something again. Okay. And then we have question 2 on page 6, problem B, 2b on page 6 is y to the negative 6 times x to the 8th. All right, well, since this is to the -6, we're creating a fraction. And we want to know what goes in the numerator, what goes in the denominator. Well, x to the 8th goes in the numerator, and y to the 6th goes in the denominator. This is the answer to the question. Okay, so since nobody's saying anything, I'm just, plodding on. And
Sorry, Professor, I have a question. Why x is the numerator?
What?
It's Lisa. Hi, it's Lisa. I'm asking
I
why.
know it's Elisa, but what is the question?
I was saying why x is the numerator.
Because there's no negative.
Okay.
See, there's a negative. This negative puts the y in the denominator.
Okay, now I get it. Okay.
But the x doesn't have a negative. X.
Okay, thank you.
Okay.
Professor, I have a question too.
Sure.
So I see now that y is at the bottom. It's not a negative anymore. It turns into positive.
Yeah. I mean, once it's like, have you ever, do you drive a car?
No.
You don't drive, but you do know that when you come to a stop sign, you stop at the stop sign, right?
Right.
When you then keep going, do you take the stop sign with you?
No.
It sounds funny, and I guess it is funny. I've been using it for 55 years, and people always laugh, but that's really what it is. This negative is an indication of what you're supposed to do. Once you do it, you leave it behind.
Okay.
So this is like your stop sign. It says, put me in the denominator. I did. Now get rid of it.
Okay.
Got it. Okay.
Thank you.
Yeah, anybody else? You have to admit, though, that was a really funny remark.
Yes, actually it was very good.
It was very good. Well, when you work on a joke for 50 years, it's got you hone it. You kind of, ask people what they think. Most of my friends think, hey, you're totally out of your mind. But it's a good, the stop sign is telling you what to do. Once you do it, then you don't need me anymore, right? You just move on. Okay? All right. So next problem is problem C. And I don't know if we have enough room, but let's assume we don't, because then we can just start with plenty of room here. P squared times Q to the -4 raised to the 3rd. Well, I would like to do this problem by the property which tells us that this gets raised to the 3rd and this also gets raised to the 3rd. Do you see? So this is, I'm hesitating for a reason. I want you to kind of focus on what I did here. This is the property. Remember the property yesterday? X to the, xy, let's say, to the n power means x to the n, y to the n. This is what that is. Each term here, each part, this is the whole term, but each part of the term gets raised to the 3rd. So this gets raised to the 3rd, this gets raised to the 3rd. So this is the property that we did yesterday that takes care of. Now we have to do this. This becomes p to the 6th. This becomes q to the -12. Okay, now this is the same exact problem as this, because this becomes p to the 6th divided by q to the 12th. Same for the same exact reason. It's just in a different place, but otherwise this problem here, right here, is the same exact problem as that. Problem E. See, this reviews everything we did yesterday. It's such a, it's a long homework assignment, But if if you didn't do this, you really robbed yourself of the opportunity to practice every single thing we did yesterday. Okay, so for this problem, we had a problem very similar to this. So we had all kinds of, remember we had a little discussion on this? So what I would do, as I said before, and there are many ways of doing it, but I would simply use the division rule, which states that when you're dividing monomials or terms of the same base, you simply keep the base and subtract the exponents. That's how I would do it, simplest way. And when you are subtracting exponents, it's regular subtraction rules, and the answer is x to the 13. And there are other ways of doing it, as we discussed yesterday. So I don't want to go through all of them, because this is the way I suggest you do it. And that is not the end of the homework. There were 2 problems on page 7. And I think these are the problems that will be on the test. I don't have a copy of the test, but I have a copy of the practice test. And let me see if I do give you a problem like that on that. Oh, yes. Yeah. That's a biggie. That's a biggie. So there is a problem, and this is the first problem. Go down. Okay, this is on page 7. Again, I'm not going to use that little space because I know I'm going to have to wind up sticking everything in and tighten. It gets tight over there. So let's not do that. Let's put it way down here where we have a lot of room. This is a word to the wise. This is on page 7, and it's problem 3b. And the problem is x to the negative 3 raised to the second times negative 3x squared raised to the negative 1 divided by x to the negative 8. Okay, so the first thing I would do is move this. No, I wouldn't do that. I would just let that sit over there for a few minutes. I just, don't bother anybody, just sit there, and that's the end of it. So what I would do is I would do this right here, this part of the problem. I would do this, and we get x to the negative 6. Just, multiply 3 times 2 is 6, keep the negative. Now, this is the problem, because you don't quite know what to do with that. So I would suggest making this negative 3 to the negative 1, and then x to the second to the negative 1. See, that's the same property as over here. It's this to the third, that to the third, negative 3 to the negative 1, x to the second to the negative 1. Then you could sort of wake up this one and say, okay, you may be needed soon. And now what I would do is take all the negatives that are in the numerator and put them in the denominator, and take all the negatives that are in the denominator and put them in the numerator. And that's pretty much, for this problem, as you could look at it, it's basically going to just flip everything over because everything is negative. So this is what you wind up with. This is what this goes in the denominator, this goes in the denominator, this goes in the denominator, and this goes in the numerator. And that's just me. If you don't want to do that, you don't have to. I'm sure there's many other ways of doing it. But I like this because this is kind of getting rid of all the negative exponent. I don't have to worry about them. So this is what happens. This is what I get. Now I would see what I could do here. Well, the first thing I would do is multiply x to the 6th times x to the 2nd. And that will give me x to the 8th divided by, hello, 6 plus 2 is 8. How do you like that? Times -3. Okay, so we got rid of these two over here, combined it, and whoa, there it is. Look at that. So that goes out with that goes out with that, and you're left with 1 over -3. You could leave that as the answer, but I think a better answer here is to put the negative in between. And that's the answer to the question, I hope. I mean, I did everything. I did everything the way I believe it's supposed to be done. Does that mean I have the right answer? No. It just means that I did it the way it's supposed to be done. But now, what am I going to do? I'm going to check it. So I'm going to do all my work all over again. Okay? I'm not just doing this for you, I'm showing off or I'm, showing you the way I want to see if I did everything right. Let me see. So this becomes this. Okay, that makes sense. This with that. Okay, that makes sense. This with this, that makes sense. And this is just hanging out. Okay. Then I decided that all the negatives shall go in the denominator, and there they are, and all the denominators should go in the numerator. Okay, that's what I did here. And then I combined these two and got x to the 8th, because 6 plus 2 is 8. And then the -3 I just brought along. But I saw that we had an x to the 8th numerator and denominator. So I got rid of them both. But don't forget, you're not just getting rid of them, you're actually dividing by them. So you're left with a 1 with a -3 in the denominator, and then that becomes -1. I feel good about this problem. So that's my first check as the professor of the class. That's my first line of checking. My second line of checking is to say to the students in the class, did anybody else get this answer?
Yes.
That's all I need to know. Who said that?
Rose.
Good. Then I feel confident. Okay, so in other words, you do everything you're supposed to do, and then you say to one of your best students, well, did I do everything right? Now, so are there any questions? Okay, then let's do problem H on the same page. And now let's use it in because it seems appropriate. So here's the problem. 2x to the 5th, y to the -3rd to the 3rd times 3x to the -3 y to the 2nd raised to the -1 power. Okay. Well, this is what I would do. Again, you could do this problem. I could come up with 5 different ways of doing this problem. But I would like to do this problem by doing 2 to the 3rd times x to the 5th raised to the 3rd, y to the -3 raised to the 3rd, and then the 3 raised to the -1, x to the -3 to the negative 1, y squared to the negative 1. See, you run out of room. That's why I didn't do it that way before, but now I decided to do it. So I basically used that same property, which is very valuable. We used it up here. Well, no, we didn't use it up here. We used it over here. Here's where we used it. We used it over here. We used it over here. Okay, so it's very valuable, this property. Now I'm going to do the actual calculations. 2 to the third is equal to 8. X to the 5th raised to the 3rd is x to the 15. Y to the negative 3 raised to the 3rd, y to the negative 9. 3 to the negative 1 would be 1 over 3. Well, you know something? I wouldn't even do that. I wouldn't even do that. You know what I would do? Because somebody had a question about that yesterday. I'm going to leave this as 3 to the negative 1. And then make this x to the negative 3 raised to the negative 1 is x to the 3rd. And then y to the negative 2. And now I recognize that there's a fractional component here. There's going to be a fractional component. So let's create a fraction line. The 8 stays on top. The 3, so that's finished. The 3 goes in the denominator because there's a negative 1 attached to it. Then x to the 15 gets multiplied by x to the 3rd and becomes x to the 18th. And then y to the negative 9 times y to the negative 2 is y to the negative 11. And now this becomes 8x to the 18th divided by 3y to the 11th. And again, before I ask somebody if they got the same answer, I'm going to just look at this and see if I feel comfortable here. All right, so I'm just looking at it, looking at it. I'm looking at it. This is 8. This is 15. This is negative 9. This is negative 1. This is the two negatives make that positive, and then negative 2. Okay, and then I drew the fraction line, put the 8 on top, the 3 on the bottom. 15 plus 3, they're both positive, so that's just 18. And then negative 9, negative 2 is negative 11. But then the negative puts the y in the denominator. I feel good. So we move the screen way back up. Very important. And we look at section 3.2. And that will give us on page 11, problem 1b, which is the square root of negative 81. Great start, right? I don't know what they're trying to accomplish here, to tell you the truth. Really, I don't know what they're trying to accomplish by taking the square root of a negative number. I think they want us to say it can't be done. I think this is what they want. There's no way they have to, because they did something like this yesterday with the square, with the fourth root of negative something, negative 81 maybe. They don't like 81. Okay. All right, so this can't be done. I think that's what the answer is. I think maybe that's what they, seems like they would say, you know, what's the answer? Of course, you could take the square root on your calculator, but that's not gonna, you're just gonna get, can't be done. You're gonna get something weird, right? So when you use a calculator for a problem of that ability, you're gonna do, second function x squared and then you put -81. Let's see what comes up. Error. It says error, which is the computer way of a calculator way of saying you can't do it. Okay, so problem 11, page 11, problem E. And that problem is the third root of -8. You see, this problem sets up this problem because you're thinking, oh, can't be done, right? But this can be done because now we're talking about not a square root, but a third root. So if it's a third root, the answer is -2, because -2 times -2 times -2 is equal to -8. It's a cube root. That makes all the difference. You can have the cube root of a negative number. You can have the square root of a negative number. All right, now the next problem goes to page 12, and it's problem 2B. And this problem is the fourth root of x to the fourth. And now the time has come for a generalization, a rule. The rule is, the nth root of x to the n is equal to x. So the fourth root of x to the fourth is equal to x. And here's the reason. Here's the reason for this. Because this is what it looks like. Right? The fourth root, and you know that you could express the index as a fraction. 1/4 of 4 is equal to x. This is the reason. And here as well. X to the n to the 1/n is equal to x. That's the reason. It's not just something you pull out of a bag. You know, it comes from a general principle. Is that clear? Okay, so on page 12, problem 2D. And that's going to be the square root of 18 a to the 5th b to the 4th. So this is like the problems we did yesterday, of course, because everything is reviewing yesterday's work. And you're going to separate this into two parts. A perfect square factor, and then the other factor. Whatever is left over, the other factor. So, for example, the factors of 18 are 9 and 2. You put the perfect square in there. What's left over? The 2. A to the 5th. Remember, you kind of got to like these problems after a while. A to the 4th times A. B to the 4th, and you don't need anything over there. And now from here, this becomes 3a squared b squared times the square root of 2a. A problem like this is on the test as well. Did I get problem I? I guess I did. Yes, I guess I did. And if I didn't, it certainly is a good problem to do because I think it's on the test. So the square root of 12a to the 3rd b to the 4th and c. Okay. All right. So, I would take this and, tell it to watch television for a few minutes, and I'd go right to this one. because this is what needs to be worked on. So same situation, perfect square, regular number, 4 times 3. A to the second times A, B to the fourth, and C, there's nothing you can do with that. And then this becomes the square root of 4 is 2, the square root of A squared is A, the square root of B to the fourth is B to the second times 3AC. But now you wake up negative 5A and you multiply negative 5A by 2AB squared. Forget about what's inside the radical. You just deal with what's outside the radical. Negative 10 A squared B squared times the square root of 3AC. So what I did was, this was outside the radical. I moved it over. Okay, forget about it for a minute. This is going to fall into one of these categories. See these problems? There was a purpose to me giving you these two problems, because they're very similar, except for that negative 5. So 12 is 4 times 3. A to the third is A squared times A to the first. B to the fourth goes over there. And C to the first goes over there. And the square root of 4 is 2. The square root of A squared is A. The square root of B to the fourth is B to the second. And then all that stuff. And then, of course, you bring back this. And this is, and really, the right way of doing this is to keep bringing this along. And I always like parentheses. So I like to use, as you know, I like to put parentheses. So negative 5 times 2 is negative 10. A times A is A squared, B squared, and then that. And that's it. That's the problem. All right, so we plow on. I did give a lot of problems, I'll tell you that. But I think I just wanted to test all, we did so much yesterday. Okay, so stop me if there's any questions. Just, yell out or something. So page 13, problem 3B, 64 to the 1/3. And that, that's similar to writing it this way. The third root of 6, what number times itself 3 times will give you 64. Now, I happen to know it's 4. I pressed a 3, then I pressed second function, that symbol, right? And then I put the 64 into it, and I got 4 as an answer, which is exactly the answer. So let me try that again. So in other words, I put the 3 in parentheses, so that may have helped. Second function, upside down V, 64 equals 4. That's it. That's how you do it. Wow. Okay. The better way of doing this is to just simply know it. I mean, you're never going to get that on a test with me higher than this. It's nice to know what the cube roots are. The cube root of 1 is 1. The cube root of 2 doesn't exist, right? So the next one you go to is the cube root of 8. The cube root of 8 is 2. The cube root of 27 is 3. This is how I did the problem. Is 4. You'll never have to worry about it. But, if you do have to worry, then the calculator's there, and this is how you do it. Whatever you think, whatever the number is, in other words, I got this from here. I got this second function upside down V from the root. So this is the actual root, and there's the 64, and I wound up with the right answer. So the second problem is actually similar. The second problem is problem E, which is 81 to the 1/4, which is really the same thing as the fourth root of 81. So let's be bold and try it again. So put the 4, then second function upside down V, and put the 81 in there. This will prove it. And the answer is exactly what we would expect, which is 3. 3 times 3 times 3 times 3 times 3. Let me write it. 3 times 3 times 3 times 3 is 81. Page 14, problem 4B is 64 to the 2/3. All righty. So again, this is going to be, whoops. Why don't you tell me if I need to drop it down? What is he sitting there? What are you doing? What is the class doing at these moments when I'm doing a problem and you can't see it? Like nobody says, put it down. What's going on? Is there anybody in the class right now?
Yes.
So how come nobody said put the screen down? We couldn't see it. It was like this, I think. And you couldn't see it. So you should have said, drop it down. So this we did already up here. Up here, the third root of 64 is 4. And then to the second is equal to 16. Okay, so we took care of that. And problem H is a piece of cake. Problem H is 25 to the negative 3/2. So right away, the negative tells you it's a fraction. And then to the 3/2 is 1 over the square is, let's separate it. So 125 to the 1/2 and then raised to the third. So that becomes 1 over 5 to the third is 1 over 125. That's the answer to the question. And that's it for that that's it for that chapter. All right, so there's no more problems. And we move on to section 3.3. So I'm gonna unless there's a question, I'm gonna erase the board. Okay, page 18. 1B. The next and last problem in the homework. This wasn't so bad. Page 19. Problem O. Is a very similar problem to what we've already done. 24 a to the third b to the second c to the fifth. Okay, so once again, 2 sets of parentheses. 4 and 6. A to the second, A to the first, B to the second. Nothing you could do there. C to the fourth times C. The square root of 4 is 2. The square root of A squared is A. The square root of B squared is B. The square root of C to the fourth is C to the second multiplied by 6AC. There it is. There's the answer to the question. And that brings us to the end of the homework.
Sorry, Professor, I have a question.
Oh, go ahead. Great. I mean, it's not great that you have a question. I'm not, it's great that okay. Somebody's talking except me. Yes, go ahead.
So basically, when I'm going to write like I'm talking about the last exercise, I first isolate like the square of 4, the square of 6, and then I combine them together. Is that okay the way that I write it, or should write it like this way?
You didn't do it the way I did it?
No, like I mean, I got the same result. It's right. I just like write separately, like the square of 4, the square of 6, and the square of the.
Oh, yeah. In other words, you did the problem like this. You said, well, let's make the square root of 4 and then the square root of 6, and then
Yes.
you did the letters.
Yeah,
Then
exactly.
you did a squared, b squared. This is the way I showed the class originally, you know.
Yeah.
Yeah, that's fine. That's fine.
Fine. Okay.
Yeah, absolutely. Separate the numbers from the letters and then do them separately. Yeah, that's fine. As long as when you finish, you put whatever is outside the radical in here like this. Okay?
Yes. Okay.
Yes. Okay, great. Any other questions? Good questions. Very good question. Love questions. Do I love questions? Yes, I love questions. Okay.